Okay, for the Test 1 Review Part 2 worksheet, we have for the very first problem says to determine the area and volumes about the x-axis and y-axis of the following. And we have for the first function, we have y is equal to 4x plus 3 along with y is equal to 0, and we have x to lie between 0 and 3. So first of all, if we look into the determination of the area in this problem, okay, we have in the construction, we have for the graph itself, we have a quadrilateral, and key corner points we have are 315, 30, the origin, and 0, 3. And we have, once again, for the given functions, we have x equal to 0, x equal to 3, the vertical boundaries, and we have, once again, y is equal to 0, and hovering above, we have y is equal to 4x plus 3. So we have, in this quadrilateral, we can determine the area from the perspective of integrating with respect to x. And so we have, from a vertical slicing perspective, y equals 4x plus 3 is above y is equal to 0. And for what we have in the determination of area, again, we can integrate with respect to x. So we have for the area, we have x is going to run from 0 to 3. And again, we are looking at taking the difference between the upper and lower functions. And again, we have the upper function at y is equal to 4x plus 3. The lower we have at y is equal to 0. And so in looking at taking the difference, so we have 4x plus 3 minus 0. And again, the difference is just going to be at 4x plus 3. And so if we go ahead and take the antiderivative, we're going to have 2x squared plus 3x as x runs from 0 to 3. So at the lower limit, the value of the expression will be negligible. So the area is going to be contingent upon what we have filling in 3 for x. So we have 3 squared is 9 times 2 is 18. 3 times 3 is 27. And for the sum of 18 and 9, okay, this will come out to 27. Right. Now, in looking at what we have for the determination of the volume with respect to the x-axis, okay, now we have in the setup, again, we have perpetual contact with the x-axis. Okay, so again, just going back to our earlier figure, okay, the quadrilateral perpetually touches the x-axis, and so we can rely upon using the method of disks. Okay, so we have, okay, now for the volume about the x-axis. Okay, now if you notice, okay, we have for the figure, okay, we have for the radius, okay, what was the height of the quadrilateral? And again, that is going to be 4x plus 3. And in the case of utilizing the method of disks, again, we're thinking along the lines of circular area. So for the volume generated about the x-axis, okay, so if we utilize the method of disks, okay, we have x going from 0 to 3, and we have for pi times the square of the radius, we have pi times the square of 4x plus 3. And as for what we have in the determination of the volume generated about the x-axis, okay, what I can do is that I can just go ahead and square out the binomial 4x plus 3, and so we have 16x squared plus 24x plus 9 and keeping pi on the outside. And you can just go ahead and take the antiderivative of this trinomial expression. So we have pi times the quantity of 16 thirds x cubed plus 12x squared plus 9x, as x goes from 0 to 3. And for the exact value on this, okay, this will end up at 279 pi. And as a decimal approximation, we have about 876.5 cubic units. All right. Now, for what we have with regard to the volume with the solid generated about the y-axis. Okay, if you notice, okay, now we have had with the discs and the washers, okay, the variable of integration and the variable concerning the axis of rotation have been one and the same. And if I were to try to integrate with respect to y in order to determine the volume of the solid generated about the y-axis, we have a bit of a stumbling block. For here we have above 0,3. Okay, you have no contact with the y-axis. So for that bit of activity within the quadrilateral that we have above y is equal to 3, we're looking at the method of washers, whereas between y is equal to 0 and y is equal to 3, you have contact with the y-axis. Okay, and so you're looking at the method of discs. Okay, and so to prevent the use of two integration exercises, we can instead utilize once again the method of shells. And so for this one, okay, in order to avoid having to do the extra work integration wise, we can just take our functions, which we have expressed in terms of y equals, and so we have, in the case of the method of shells, okay, again we can integrate with respect to x, and again we're going from x equals 0 to x equals 3, and we have 2 pi x, and again you have the difference between the upper and the lower functions. And so in looking at what we have in the setup, okay, so taking the product, this time around we have the binomial expression 8 pi x squared plus 6 pi x and so for what we have in the attainment of the antiderivatives, we're going to have 8/3 pi x cubed plus 3 pi x squared. So x goes from 0 to 3, and for the exact answer, okay, this will end up at 99 pi and in terms of the decimal value we have about 311.02 cubic units. Okay, and so that particular portion will complete exercise number 1.